Hari Om. Students, look at the screen, watch and listen carefully. Your today topic is cell. In electricity, the cell is an important topic. First of all, you know what is the cell. Cell. A cell is a galvanic or voltaic cell, a source of electrical energy in electric circuit. Energy. Cells converts chemical energy into electrical energy. Battery. Two or more cells connected in series or connected end to end form a battery. Duration. Primary cells have one time use and are not rechargeable. A typical cell has a voltage of 1.5 volt. Now, definition of cell. An electrolytic cell consists of a container filled with an electrolytic substance and two electrodes, namely positive and negative, dipped in the electrolyte. As you see in the figure, there are two electrodes, one is anode and one is cathode. And the electrolyte also used in the vessels. There is an exchange of electrons and positive ions between the electrodes and the electrolytes. The flow of electrons and ion constitute the flow of current in the cell. That means clear how current is flow in the cell. Now, electromotive force, that is EMF. The potential difference between the electrodes when there is no flow of currents is called the EMF of the cell. When current flows in the circuit, it faces opposition from the electrolyte in the form of internal resistance of the cell, that is denoted by a small r. If load resistance is denoted by capital R, is connected across the cell and current I is flowing in the circuit, then V is equals to IR equals to minus IR, where V is the drop across the load resistance R. Therefore, I is equals to I R plus R. Maximum current from the cell is drawn when there is no load and it is an open circuit. In such a case, that is capital R is equals to 0. Then current is maximum and it is equivalent to IR. Now, how the cell are connected in the circuit, that is combination of cell. The cell are connected in the circuit by two ways, series combination and parallel combination. And the third one, the mixed. That means you can connect the cell in series and parallel both. So first of all, in series combination, you look in the figure, there are two cells whose EMF is E1 and E2. Internal resistance R1 and R2, that is connected in series. The current I flows from C to A as the given figure, and the equivalent circuit is given below, that is E equivalent, that means equivalent EMF, and R EQ, that means equivalent internal resistance. Here we find the expression for both. Here you find that the derivation is: consider two cells with EMF E1 and E2 with internal resistances R1 and R2 connected end to end or in series. Let the current in the series combinations be I. The voltage across the two cells is equal to V equals to E1 minus IR1 plus E2 minus IR2. Therefore, you can write this expression: E1 plus E2 minus I R1 plus R2, that is equivalent to V equals to E equivalent minus IR equivalent. On comparing both, E equivalent equals to E1 plus E2. That means equivalent EMF is equals to sum of the EMF of two cells, and equivalent resistance is equals to the sum of the internal resistance of the two cells. That is, the two cells can be replaced by one equivalent cell whose EMF is equivalent EMF and internal resistance is R equivalent resistance. If the cells were connected with the negative electrode of the first cell to the negative electrode of the second cell, then the EMF of the equivalent shell would be given below. Now, cells in parallel. You look at the figure, the two cells are connected in the figure and their equivalent circuit is given below. The cells are connected in parallel combination. Let us suppose the current I1 and I2 are flowing through the cells whose EMF are E1 and E2. The voltage is given by V is equals to E1 R2 plus E2 R1 by R1 plus R2, and I minus I R1 R2 by R1 plus R2. If the parallel combination of cells is replaced by a single cell of EMF, then equivalent EMF and equivalent internal resistance 1 by R equivalent is equals to 1 by R1 plus 1 by R2, and E equivalent by R equivalent equals to E1 by R1 plus E2 by R2, as you find in the figure. Now, applications. Some applications, you look in the figure. Cells are extensively used in a wide range of household and industrial applications like watches, calculators, torch. Now, you look the construction of the dry cell. Parts of the cell are shown in the diagram. Now, thank you, and I hope you will understand more about the cell, how the cell is connected in series and how the cell is connected in the parallel, and how can you find their equivalent EMF and equivalent internal resistance when they are connected in series or in parallel. Thank you.